So we'll have a connectivity. I'll explain the topology. So this link for time being we don't want. So this is a previous lab. So just how configured the interfaces. So IP interface brief. I have configured towards this interface 11.1.1.1 and 192.168.10.1 is the LAN interface. Same thing I have configured the ISP router also directly connected interfaces. Do show IP interface brief. You can verify. So directly connected interfaces only. So here also same thing, only LAN and WAN prefix I have configured. Do show IP interface brief. Only we have a LAN prefix and WAN prefix. So we configured as a host also. IP addresses we have send statically. Good. This is what the topology. Now we'll configure OSPF routing protocol in between these routers, router one, this branch one and branch two, and apart from that, this ISP also. And we'll advertise these prefixes LAN and WAN, and here whichever the directly connected interfaces will advertise. So before that, what I will do, I'll create one loopback interfaces for, and I'll create one loopback interface for every router. So how the router will elect as a router ID, we have to know. So config T, loopback interface is a virtual interface. Loopback. So before that interface, loopback, just use one or any number. To this range, you can use any number. To this many range, you can create the loopback virtual interfaces. I'm using one. So I'll give the IP address for this 1.1.1.1 and subnet mask is 255.255.255.0. This is a loopback of this router, branch 1 router. And I'll configure same on branch 2 router also, but loopback interface loopback is here 2. For that, I'll give a IP address 2.2.2.2 because it's a branch 2. That is the reason for our understanding purpose I'm giving 2. So I'll give this router as a I'll not give anything. Why? If we give, we can easily understand. So we'll give some router ID config T. Already we are in global configuration mode. Interface loopback 100 I am configuring. So IP address for that 100 dot 100 dot 100 dot 100 and 255. Instead of 100, we'll give something else because it will be elected as a router ID. It will be elected something. So okay, 100 only. Anyway, we have configured there 255, 255, 255 at 0. Now, show IP interface brief. So this is what we configured. Through IP address, you can verify the whichever you configure, and by default, it's R up only. So router ID I have configured 1.1.1 here. Now I'll exit and I'm configuring here OSPF routing protocol. Now configuring the OSPF routing protocol, just a router OSPF use any process ID in gateway. If process ID also mismatch, no issue. It will be from the neighborship. Process ID where will use at ISP level, internet service providers. They will use because they have multiple customers. So for understanding purpose, they will use different process IDs for each customer. If they have 100 users, means they will give each user one process ID. So here we are giving 100 and we'll advertise. Before that, if you want to configure router ID, so here we have a command router ID. Yes, so router ID, whichever the ID you can give, that will be elected. It is a manually we are configuring. If you are not configuring manually, the router will elected based on the whichever the loopback interface. Multiple loopback interfaces, in that it will be elect whichever the highest loopback interface, that will be elected as a router ID. So we'll advertise some prefixes here LAN and WAN 192.168.10.0 and here we'll use same thing. And earlier we used like Wildcard mask. Here also we are using wildcard mask. 0.0.0.0.255, and here we have to use area concept. If you are hit enter, it won't take. So here you have to give the area, whichever the area. So area should have to match. If area is not matching in this in segment, it won't form the neighborship again. I'm using here area 0. So again one more network 11.1.1.0 and wildcard mask 0.0.0.255 and area is 0. So then again I'll configure here the router. Yes, config router OSPF 100 and network 11.1.1.0 and wildcard mask 0.0.0.255 and area should have to match 0. It will be formed. It will be compared to EAGRP. The convergence is slow compared to EAGRP. Yesterday we configured EAGRP. The convergence is very fast, but in OSPF the convergence is slow. That is the reason till we haven't get the neighborship. So again we'll advertise different interface IP address 12.1.1.0 and 0.0.0.255 and area also 0, and we'll configure in this router also exit and router OSPF 100 and network is here 12.1.1.0 and wildcard mask 0.0.255 and area also 0, and one more network 192.168.20.0 and wildcard mask 0.0.0.255 and area is 0. Yes, I have configured entire thing. So now we'll check the neighbor table. So IP OSPF neighbor. So this is what they are in two-way state still. So so convergence is forming. See here is the they are in two-way state. Two-way state. The convergence is forming. The here you can check the neighborship is formed. Now you can check neighborship is formed. In two-way state, election has done. After then, first it will be down any two-way start exchange. Then they will be moved to the loading and full state. That is what you can verify here. Two-way state. In two-way state, D or other router. In which router will struck in two-way state? It's an interview question actually. In two-way state, which router will struck? So D or other router will be struck. That is the answer. Only one line answer. Show IP OSPF neighbor. Now you can check. Now it's DR full and this is the state. So we have a one neighborship, that is the DR router, and that is connected to this interface 12.1.1.1. The interface is fast Ethernet 0 by 0, 0 by 1. You can check here. That is the interface is fast Ethernet 0 by 1. They are connected. The neighbor router having the router ID, whichever we configure the loopback IP address, that is what 100.100.100. If you want, you can verify. Earlier we configured this is 100.100.100, and you can verify in this router how many neighbors are there. We are verifying the neighbor routers. Show IP OSPF neighbor. This router should have two neighbors. One is towards branch one is towards branch 2. This router having two neighbors. Just verify here this router. Those are the VDR router. So here you can verify. Okay. And these are two neighbors this router having, that is 1.1.1. This one is the 1.1.1 and this one is the 1.2.2.2. This is the router ID. And so we'll check the global routing table. So IP route. So this is the global routing table. This router are getting two in LAN interfaces. This is 192.168.10.0. This is a one LAN interface and this is a second LAN, branch 2, branch 1. So are this router are getting two LAN interfaces through OSPF. O means here you can say OSPF. O means OSPF. O means here OSPF. This is the global routing table. If you want to check individual OSPF table, so here, so IP route OSPF. This is what. Only we can verify through this command only OSPF routing table. So if you want to verify which configuration we did in OSPF in real time, so running configuration pipe section OSPF, use this command. Whichever the running configuration you did, you can verify through this command in real time. Use this command. This is a troubleshooting command actually. If you want to check the database table, so IP OSPF database. So this is the database table. Here we are getting two LSS. One is the router LSA, another one is the LSA2, that is link LSA. So here you can verify in router LSA, entire routers having whichever the area zero. This all is the this one is the area zero actually. This is the entire is the this one is the entire is area zero. Only area zero we configured. Area zero we configured here. That is the reason showing this entire prefix are in area zero. So that is the reason. If you are configuring different area, so okay, what I will do, I'll create one loopback here. Config T interface loopback. I'll create 10 and I'll give the IP address for that. IP address is here. I'll create 20 and I'll give the IP address for that 20 dot 20 dot 20 dot 20 dot 20 and 255 255 255 dot 0 and I'll advertise this prefix in a different area. Router OSPF 10 and no, I'll use here 20 because it's a router 2. Before that, how you will, if you want to remove the different OSPF, just use no and router OSPF 100. This is what we taken the process ID. So, so now network and we'll take which network we configured 20 dot 20 dot 20 dot 20 and here we'll give the subnet mask wildcard mask is 0 dot 0 dot 0 dot 255 and advertise this prefix in area 20 branch 2. So now you can verify here again in database table only. So IP database table. Here you can verify. This is a ABR router means area border router. Different through different area we are getting. Earlier only we are getting at only we are getting router 1 and router 2 LSS. But here we are getting through this router ID. This is a different area. That is the reason it is elected as a. It means it will be different area through different area we are getting. But here you can see who is advertising ADV advertising router. Advertising router is this router only. But which prefix it is advertising 20.20.20. This is a different area actually. If you want to check that thing, you have to check in this routing table only. So IP OSPF database. So here, area 20 and area 20 also we are getting this many prefixes. So what does that I mean to explain here? So here these many prefixes we are getting. So these all are the link state advertisements. So in OSPF, the good thing is there, entire routing, entire topology information they will maintain. So this is the ABR router, area border router. We configured one virtual interface here. We configured one of the virtual interface here. One is the loopback interface. Loopback interface that is 20. That is a different area actually. This is a area 20. That is loopback interface. So for time save purpose, I have configured. So I have shown that different area. If you want to verify that prefix in this router also, yes, you can verify it. Enable config T, no, show IP OSPF database table. So here you can verify that is summary LSA. Summary means again that is the ABR router LSA 3. So this is all about the OSPF configuration, and here we have a three routing tables. One is show IP OSPF neighbor table. This is the neighbor table, only one neighbor connected. One more is show IP OSPF database table. The database table it will be consider it will be carry the entire link state advertisement link entire LSS entire LSS it will be it will be visible here through this command. One more is show IP route. It means routing global routing table. If you want to check only see IA. IA means different area. You can check it. Infer area. It means different area. It is a different area. IA. O means OSPF. This is the advanced things. It don't confuse. Whenever you are seeing in your production network, don't confuse. Likewise, also it will be happen. Don't confuse. So IP route OSPF. If you want to check the particular route in OSPF, whichever we are getting, yes, we can verify this through this command. Okay, good. This is all about the OSPF. Just use this command only. So running configuration. This is what we configured in OSPF. Just reline configuration. This is your task. If you have any questions, ask me please.